In this video I'm going to show you how to model graph transformations with EMF and Henshin and how to generate an executable application for Apache Giraph. You need a recent installation of Henshin, so you can install Henshin from one of our update sites. Just visit our webpage. So we're going to start from scratch here. So first we create a general project. We're going to call it foobar. And really the first step that you need to do is to create an EMF model, an eCore model. If you have an existing eCore model, that's just fine, but for our purposes we're just going to create a new one here. Let's call it foobar. And this eCore model will define the classes which will be used as node types in our Giraph application later. So we just have to set some basic properties, so the namespace prefix, and the namespace URI of the package. And the first step that we do is that we just create two classes. So the first one is called foo, and the second one is called bar. And really this would be here the classes that you need for your application. So let's say that the class bar inherits from the class foo, and we're gonna add one edge type to foo, and this will be of type bar and will be also called bar. So this will be our domain model, and for our purposes this will be enough. So in the second step we're going to create a very simple transformation using Henshin. So we're going to choose now a Henshin diagram. We create a new Henshin diagram. Let's call it also foobar. And we're going to import the eCore package that we've just created. What you see on the right hand side is that we have now the classes foo and bar, and the first thing that we do is we create a new rule. Let's call it first, and we're going to create a couple of nodes. So we're going to create here 3 nodes, one foo node and 2 bar nodes. And we're going to add some edges between foo and bar here, and bar. So by default the actions are set to preserve, which basically just matches these nodes. So for example, what we do now is that we change the action of the second bar node to create. So this will create this node. So what's important now is that we have to add the cleany star to all nodes. And you see also this shadow behind the nodes, and this basically says that we're gonna apply this rule for all possible matches. So this is important for whenever you generate Giraph code, because right now Giraph will work really on all matches. So let's create a second rule. Now this rule matches one foo node and one bar node, and what it does is it basically reverts the edges. So what we're gonna do is we are deleting the edge from foo to bar, and we're creating a new edge from bar to foo. And again we use the cleany star here to apply this rule for all possible matches. And this is important if you want to generate Giraph code in the moment. So now we have 2 transformation rules, and for the orchestration we're going to use a sequential unit, which we'll just call main. And this sequential unit will just execute the rule first and then the rule second. And it's important to know that these 2 rules are applied separately to all possible matches. Okay, so this is our transformation. Now what we have to do now is that we are using this context menu action to generate Giraph code. This will open up a wizard, and in this wizard you first have to specify a project name, a package name, and the name of the main class. So there are a couple of options. So you can use here, for example, you can set that Java UI IDs are supposed to be used for vertex IDs. Then there is another item for setting up a test environment. So we're going to use this here. This will install a local Hadoop installation which will run only on your local host. And then there are a couple of more options. So now in the background it's generating the project. So one thing that's important is that Giraph currently has some problems with the host name. So you should make sure that your host name has only lowercase letters. So if you have some uppercase letters, I advise that you change it to lowercase letters. And the second thing that you should make sure is that you have public key authentication enabled for your local host. So you need to be able to SSH into your local host without giving password. And this is basically, these are two commands that you can use to make this setup. So these are two important things that you need to be aware of. So meanwhile, our generation is finished. So we see a new Java project here. This Java project includes two generated classes, one utility class and one main class. So the main class contains the code for the implementation of the two rules and of the sequential unit. And feel free to browse through this code and to just get a feeling what's generated. And this is really a Java project, and you see here that we include the sources of Apache Giraph here. The project is built using Maven, but it's also integrated with the native Eclipse Java build environment. And you see here also that all needed libraries are automatically added. Then there is one input folder, so the code generator automatically generates an example input file, so we will take a look at this later. Then there is also a launch configuration, so you can use this launch configuration to start your transformation. And then there is a target folder which contains the jar which you can execute in your Hadoop environment. And then there is also a test end folder, and this test end folder contains the test environment with Apache Hadoop. So we're going to launch now this test configuration, and now you really see how the Hadoop services are started. And meanwhile, let's take a look at the input file. So this is a generated input file. It's a JSON format, and you see here two nodes. The first item in the first line is the node ID. The second item is the node type. So here 0 stands for foo, and 2 stands for bar. And after that you see the edges. So you see one edge from node 0 to node 1. So this is our input graph, and this is automatically generated as an example. And what our rules will do is they will match these two nodes and create a new node of type bar with two more edges. And then the second rule is applied, and the second rule will revert the two edges from foo to bar. So on the bottom you see now the execution. So the Hadoop services are started. You see the starting of the data node, the name node, the job tracker, and you see also how the Giraph job is started. So you can also launch this using ant on your command line. So you just have to run then ant -f main XML. So this is an easy way to start also on the command line. And you see here now that the Giraph job is done, basically. So afterwards, the Hadoop services are automatically shut down. So this takes a couple of seconds. And you see here also that Giraph already generated a couple of statistics for us, including the number of aggregate vertices. So we see that in our output graph we have 3 nodes and 3 edges. Okay. So, and now we can take a look at the output folder, and the output folder contains the output separated in 2 files. So we see here we have 3 lines, and each of these lines refers to one node. So we have 3 nodes. The first one is the foo node on the right hand side. It has no outgoing edges, and on the left hand side we see the 2 bar nodes, the first one with 2 edges and the second one with 1 edge. So the edges are reverted now and point to the foo node. So we see that apparently the rule was correctly applied. So one node was created and the edges were reversed. Okay, so this is basically it. So I've shown you how to model a simple transformation using EMF and Henshin, and how you can generate executable code for Apache Giraph.